Lesson 8. Analyze a manufacturing questionnaire. This is a setup file that stores individual parameters that are used by the scripts. So you can adjust, for instance, the distance of your screw hole set out or your hinge drillings and other parameters. Typically you set up your company standards once and do some adjustments. But it's still good to know a bit more about it. Let's see a bit more how this works. Let's just draw a few cabinets and then we run them through Analyzer Manufacturing. Let's do a simple one-door cabinet. Then we do one with drawers. Let's do 4 drawers. Let's just place them next to each other so we can select them individually, and possibly a corner cupboard as well. Now let's set in the job settings the construction method to screw and dowel. Now let's create 3D of each of those. Do a couple of changes so we can see how the questionnaire is influencing the scripts. So, for instance, this one, we want to change the construction method. We want to do just a screw construction for that. Go to Part Properties. Select this assembly, it's base 2. We change that to just screw. Go to Edit. Change it to screw. We save it. We click at it. Press OK. Now all we need to do is we have to set next, and we set all. So now all those parts have been changed to a screw construction method. And this one we're going to change to a cam vertical. It's base 3. Cam vertical. Set all. Then the other thing what we want to do is we're going to change the top rail just to see how some of those limits influence the drilling. Change our pick style. So this one, it's now 150 wide. So we change this by 60 millimeter. And we do the same thing on this cabinet. So now it's 90 millimeter. Now let's export them to Analyzer Manufacturing. So if you look at the top rails, for instance, you probably notice in our screw cabinet, they are slightly have different distances here, this one. Now this is influenced by questionnaire settings. Press Script Setup. You see there's different settings that you can do: generic, shelf, drilling, hinge, horizontal cam, and so on. So in a generic part, it basically just tells you the available drills that you can do. The DXF holes, they're used for machine blocks. So that's all the ones, available ones, and what drill type it is and so on. So that's your setting. That probably doesn't change much. There's some dowel settings too, how deep they have to be drilled. Now, for our screw settings, the first part tells you the drill diameter that's used for the screw construction. It's a 5mm drill. Drill type is automatically the 10, and the drill depth is 0.2, so that drills slightly through the board by 0.2mm, and we don't have any end dowels, so that's set to false. Now, there is a limit, so when parts get too small, it will drill slightly different. So the limit 1 is set that it distributes them equally along there. So if we look at our front rail here, this is to limit 1 because it's less than 150mm. So what it has done, it has put the two screw holes equally spaced. So they would be 30mm apart. You can check this. You can go to draw. You want to do a vertical measurement line. You select center. You select endpoint. It's exactly like AutoCAD. So 29.99. So that's 30mm. So the 90mm wide front rail has been spaced in 3 equal spaces, while the 150mm back rail has used a different distance here. So you can check this in the questionnaire settings. It's used to limit 2, which uses a 50mm setting from each side. That goes up to 192mm. So this is our limit 2 settings. So we can double check this. So that's our 50mm there. While the bottom has used the limit 3, or the standard limit, which when we look at this here, it has an end offset of 32mm. So again, check this. That's our 32mm. Now for your limit 3, there's also a screw distribution distance of 350mm. That tells the analyzer scripts what maximum distance it has to drill on distances wider than 192mm. So if it's anything wider than 350 between the outside 2 screw holes, it'll put the second hole in it. A dowel construction is pretty much the same than a screw construction. You got limit 1, limit 2, and the dowel distribution distance. In this case, we don't have any values in the fields, but it will be using the default values, which are the dimmed values here. In addition to that, there is some more settings in the generic settings for dowels. It tells the script which drill to be used, an 8mm diameter, drill type, the vertical drill depth that's into your horizontal panel, and the horizontal drill depth that's into the edge, and that's 25mm deep. If you use screw dowel construction, it's a bit of a hybrid of both. So you can see here in the screw settings, there's for the screw dowel construction, there's two fields here. It's the dowel offset of the edge here, 64, and the screw offset at 32, so make sure that they don't interfere. So we can adjust that. And for limit 2 and 1, it's using those settings for the screw drillings, 50 mil. You can see that here in our screw dowel construction. That's the 32 and 64 millimeter distance on the bottom. The front rail is using limit 1. It's not enough room for a dowel, so it just puts two screw holes there, equally spaced. And here is the 50 millimeter distance in the center dowel hole there. Let's have a look at the vertical cam settings. So you have a vertical cam construction, so you basically have on a vertical cam construction, you need to drill a hole for the cam, which in this case is a 20 millimeter diameter hole, and a hole for the pin. So those settings you will find here on the vertical cam settings. So first is the diameter of the cam, the diameter of the pin, that's a 5 millimeter hole. Drill types, and then you got the drill depth of your cam and the distance. So as you see here, the drill bit is slightly outside of the panel by about 0.5 mil. So that's why you see the 9.5. And the same thing is with the pin. You have a fixed size there, and this 8 millimeter is the distance of the primary surface. That's basically the inside surface in our case. Then you have the limits. It's the same. Then your drillings basically in a very similar manner. Let's have a look at hinge hole drillings. In our instance, we're using a Bloom inserter hinge. We need to drill the boss at 35 millimeter and the two 8 millimeter holes each side, which are 45 millimeter apart and 9.5 of the center of the main drilling hole. So if you look at the questionnaire, we go under hinge drilling settings. The first line here is for the mounting plate settings. So it tells you the drill depth, the drill diameter, drill type, and the offset of the center. In this case, it's one of those cross plates. They are 32 millimeter spaced apart, so that's 16 millimeter each side, and it's 37 mil from the edge of the door. So basically, talking about these holes here, there for your mounting plate. So it's 37 mil off here and 32 mil apart. Then the actual hinge settings here. Drill depth of our main drill, the 35 millimeter diameter, it's 13 millimeter deep. You can also round a pocket if you don't have a 35 millimeter drill, or you prefer to route it rather than drilling. You can specify it here. This is for standard hinge. So it's a diameter, and the offset of the center is 22 millimeter. So that's off the edge of the door. So it's 22 millimeter off the edge of the door. Then for your screws, there are those 8 millimeter holes in our instance of the inserter. It's 13 mil deep again, 8 millimeter diameter. The offset, X offset is 22.5, so remember it was 45 apart, so that's 22.5 each side. And the offset Y, that's from the edge of the door again. So basically it's the 31.5 minus the 22. So that's the 9.5 that you see here. Then you have settings for a bifold hinge. That's when you have a corner cupboard or so. That's a Blum version as well. It's 12.5 instead of 21, so it cuts a bit out of the door. As you can see that. Let's bring up the bifold door. That's a part of this corner cupboard. So you see that door has a hinge hole drilled slightly outside the door. So that's the setting here. That's a 12.5. But the only other parameter that you need for the bifold door is the plate offset on the other door. And that's the Y offset here, the 20mm here. That's your 20mm here, that's the distance there. So that's basically all for the bifold door. Now the other thing is the number of hinges placed. For up to an 800mm door, it's 2 hinges. Up to 1400, obviously it's 3, and so on. If your cupboard is small, let's say only 500 high, it also spaces the hinges slightly different. So it starts only 60mm from the bottom and from the top, while on larger cupboards it goes to 100. If you have a flatbed CNC machine and you nest your panels in one sheet, you will be required to set up those DXF nesting router tool defaults. This allows you to control the tool diameter for your various thicknesses of board. So in that case, the tool number 1 is your 10mm tool, and you can adjust the depth. So 0.2mm means it's cutting slightly into the baseboard in your flatbed router. So it's 0.2mm minus actually. And the same thing here. If you go to thicker materials, it'll use the tool, the 12mm tool, and the same thing, it cuts a bit deeper. And then you can adjust different materials. So if you have anywhere in your material specified MDF, it'll use a different tool here, tool number 2. Quite often you want to use, for smaller diameters, you want to use a 2-wing cutter rather than a 3-wing, because the dust of the MDF is clogging up your 3-wing tool. On thicker materials, like from 26 onwards, you're using still tool number 3, there's not such a problem of clogging up your tool. You can do other materials like solid surface or so, and you can use different tools here. So plywood, sometimes you'll be using a different cutter. So you have another total of 5 extra materials that you can use. The same thing is for your pod machine. The only thing is you probably vary the thickness. You don't want to cut all the way through. You want to keep it 1mm above the machine table here, so you put the -1 in there. And the same thing, you're setting up all these different tools for your different materials. If you do a lot of benchtops, you can just put your benchtop connector settings here. One setting is for the slot and the other one for the hole. If you have 2 parts specified as benchtop and you butt them together, it will automatically route your benchtop connector there. We have 10 different drawer styles available here that you can configure to your type of drawer that you're using. In this case, we got tandem box runners, so you got the tandem N type. Your style 2 is your very standard tandem M style, and so on. And there's a few Legra box as well here, Legra K, and so on. Let's have a quick look at the tandem M style. That's the one that we're using on our cupboard here. So, as you can see in the parts, we specify in the part type on the various parts, and back, bottom, and front, we specify the type of drawer that we're using. In this case, it's a tandem M. So, we got the following settings. The first is the front drilling. Then we got end drillings that goes into your cupboard end, and there is sometimes back drillings as well. and even some on the bottom, and you can do routing in the case of a Lego box. So let's have a quick look what all these settings are. Your drawer front drilling, you see 38.5 in the X direction and 70.5, and a Y offset is 22. They are the following. That's your 38.5. That's from the bottom face of your drawer bottom. That's basically where your runner is fixed to. The second hole is 70.5, and your 22 are from the edge of the bottom. So that's those sizes here. And it's a 10mm diameter hole, 12 deep. The end drilling, that obviously varies to the depth of your cabinet there. So the first row here is the diameter of that drill, how deep it has to be, tool type, and the first row distance. Sometimes they have two rows on the sides, and this one here is a 24mm, so that's looking at the end panel. That's that distance here from the bottom surface again to the first row hole here. Sometimes there's a second hole here. You can specify that too if you need the strength. And the other holes, your first hole is 19mm from the front edge, the second one 37, and so on, yeah, and then it switches over to 35. So you have to set it up for each type of drawer and for each length of your drawer runner. The back drilling, that's your back plate if you have one. That would be the one that's used on your drawer backs. So you see there's a drawer back here, there's two holes here for the angle bracket. So that's the settings here for your back drilling. And for the bottom as well, that depends too on drawer length here. Usually the first two are the same and then it changes. That's your drawer bottom here, that's those. It's your drawer bottom, that's those holes here. In case of a Lego box, you can do a rebate at the bottom as well. Style 7 for instance, just Lego box M. You will see there is some rebates to be done, so you select that to true and then you specify the tool number, which is your trenching tool, and then the diameter and the rebate width and depth. And that always goes from the bottom surface of your drawer bottom. When you're testing your scripts, make sure you save the questionnaire here. Save. And sometimes you can rerun the scripts, but preferable you reload your cupboards into Analyzer again, import them, and run the scripts. Then you're sure it's going to work. So that's basically all for lesson number 8. Thank you for listening.